So the refraction of the light, the refraction means the property of a light to change the speed when it travels from one medium to another. Now we'll do some examples related to refraction and different conditions. So ray diagrams to show refraction of light. And always remember, when it is moving from air to glass or water, then it will bend towards the normal or speed decreases, and opposite will happen when the ray of the light is traveling from glass to air. It will bend away from the normal or the speed will increase. So different scenarios. Example, refraction. The first one is refraction through a glass block. Or rectangular glass block. So if you want to show a refraction through a rectangular glass block, so this is a glass block which is rectangle, and the ray of the light which incident, this is a light which incident. So what we do, we draw imaginary line which is perpendicular to the surface is normal. So always whenever a question is there, you will always draw the normal. So the imaginary line, in reality it's not there, it is just imagination, so that we draw normal. Now moving from air to glass, like this part is air and this is a glass. So moving from air to glass, what we will observe, this light ray will bend towards the normal, speed decreases. So if we draw straight, it means no change in direction. If I draw other way around, it means bent away because the angle is increasing. But because when the light is moving from air to glass, it bent towards the normal, and don't make to like it is towards the normal, not in the direction of normal. So it should be slightly bended towards the normal. Then you will draw the normal again. Normal is always perpendicular to the surface. So another normal we draw. Now it is moving from glass to air. So as it travels from glass to air, this is the ray direction. This will be bent towards the normal and this will be bent away from normal. So this is how the ray of a light will pass through a rectangular glass block. Is it clear, the first part? Any doubt in the first part for ray which is passing from air to glass and then from glass to air? So we have air, glass and air. Now this ray of a light is passing directly along the normal. So it is passing directly along the normal. So this is the ray of a light passing. And when we draw the normal, so the normal is same as, so the direction of the normal is same. So when the direction of the normal is same, what will happen? In this case, it will pass straight. And then when we draw another normal here, normal is always 90 degree or perpendicular to surface. So when we draw the other normal, again what happened? Because it is passing along the normal, so it will pass straight. So there will be no change in the direction for the light ray, only it will change the speed, but it won't change the direction. So these are the two things which might happen when the ray of a light is passing through a rectangular glass block. Then another refraction, example of refraction, refraction through prism. A prism is having the sides like triangle sides for the refraction. So this is a glass prism. So this is a glass prism. The ray of the light strike the prism, and when it strike the prism, we will draw a normal here. So normal is always 90-degree to surface. So if this is the surface, when we draw the normal, the red line is actually the normal. So this is how the because the normal and the surface should always be 90-degree to each other. Now when we try to complete this light ray, so what happen if I draw in this manner, it means it does not bend. If I move up, it means bend towards the normal. But because it is moving from air to glass, so it should bend toward it. If I bend up, it is away from the normal, and if I bend down, it means it is bending towards the normal. So I have to bend down to show that it is bending towards the normal as the speed is decreasing. In air it is traveling faster, but in glass it is traveling slower. Then how the refraction occur? So again we'll draw a normal. The normal is always perpendicular to the surface. So this is the surface now. So when we draw the normal, the 90-degree line, so this is the red line is representing the normal. And we want to complete the ray. So first, if I draw straight, it means it does not change the direction. But moving from glass to air, it should bend away from normal. So if I draw like this, it means it is bending towards the normal. So I should further bend down, which means it bend away from the normal. So this is how the ray of a light will pass through a glass prism. So moving from air to glass, it slow down and bend towards the normal, and moving from glass to air, it speed up and it will bend away from the normal. Is it clear? Any doubt till this point? The refraction of a light, the change in direction of the light when it is passing from. Then another example, uh, refraction through semicircular glass block. So these all ray diagrams you should practice, because in exam they ask to complete a ray diagram to show the path. So you should be able to draw these. So example, the semicircular glass is there. Semicircular glass means the glass, one side is a curved surface and the other side having a flat surface. This is a semicircular glass. Now, how the refraction occur in a semicircular glass? First, the ray of a light is passing. So when the ray of the light is passing, when we draw the normal is always 90 degree to the surface. So when we draw the normal is perpendicular 90 degree to the surface. So the normal and the ray in which direction in which the ray is entering, they are all same. So whenever normal and the direction in which the ray enter, it only changes the speed, it does not change the direction. So the ray will pass straight. And when it will pass straight, again we'll draw a normal which is perpendicular to the surface. So this is the surface. So when we draw the normal will be perpendicular to the surface. And moving from glass to air, it will bend away from the normal. So what will be the path it will follow? So it will bend away from the normal. So this is the path which the object will follow when it is moving from moving through a semicircular glass. First from air to glass. Why it does not change the direction here? Only the speed will change. No change in direction. Sometimes they ask why the ray does not change the direction. So what should be your answer? Your answer is because the ray is passing along the normal. So as the ray is passing along the normal, that's why it does not changes the direction. Is it clear? The ray, the refracted ray or refraction of a ray when it is moving through a semicircular glass block. Then another refraction through convex lens. What is a convex lens? A convex lens, a lens which is thinner at the edges and thicker at the center. This lens is known as convex lens. So how we will show a refraction of the light through a convex lens? So example, this is a light which enter. The imaginary line which is perpendicular to the surface, that will be normal. So when we draw the normal will be perpendicular 90 degree to surface. When the ray of a light is moving from air to glass, it will bend towards the normal. So this is how it will pass straight. But because we want to show like this is it pass straight, we want to show bend towards. So it will bend towards the normal. And then we'll draw a normal again. Normal is always perpendicular 90 degree to surface. So this is the surface. So when we draw the second normal, this is the 90 degree to the surface. And moving from air to glass, what happened? It will bend away from the normal. So as it bend away from the normal, it will follow this path. So this is how the ray of a light is refracted through a convex lens. So always remember, from air to glass, bend towards the normal. From glass to air, it will bend away from the normal. Another example, refraction through concave lens. What is a concave lens? A concave lens is opposite. A lens which is thicker near the edges and thinner at the center. That is a concave lens. So how we can represent a refraction of a light? Say the light is passing straight. We draw the normal. The normal is always perpendicular. So this is How we draw the normal? Moving from air to glass, it will bend towards the normal. Then we'll draw the normal again. Then moving from glass to air, it will bend away from the normal. So further, it bend away from the normal, like when we complete the ray diagram, this is without changing the direction. If we bend downward, it is bent towards the normal, but it bend away from the normal. This is how we represent a refraction of a light through a concave lens. So these examples you have to understand, like the refraction. The first one is refraction through a rectangular glass block. The second one is a prism. The third one, semicircular glass, convex lens, and concave lens. Then there's a term which we use known as a refractive index. What is the term refractive index means? Refractive index means ability of the medium to bend the light. Like tendency of a medium to bend light, we call that as a refractive index. It's a comparison, like we have two types of glasses, glass A and B. Why it does not move downward? As you can see in a concave lens, when we draw the normal is always perpendicular to the surface. So this is a surface, so this one is a normal. Now you have to continue the light, like this is the direction in which the light is coming out. This is the direction in which the light is coming out. So if I bend downward, it means the speed of the light, it is bending towards the normal. So speed is decreasing. But because when the light travels from glass to air, its speed increases. So it should bend away from the normal. That's why we move it up. This is how the light is traveling. It should be straight line. But if we move down, it means it is bending towards the normal. So we have to bend up because the speed is increasing. So refractive index is ability of the medium to bend the light. The tendency or the ability of the medium the other one, why it moved downward? Because you have to continue the direction. As you can see here, when we draw the normal, this is a normal. Now we have to continue according to the ray. So this is the direction in which the ray is coming out. So if I bend up here, it means it is moving towards the normal, but because the speed is increasing, so it should move away from the normal. So in this example, the ray is coming on the right hand side of the normal, but in a concave, the ray is coming out from the left hand side of the normal. So the side where it is coming out from the normal, that is different. That's why the direction of the bending is different in concave and convex. So refractive index is the ability of medium to bend the light. The one which will have greater ability to bend the light means it will have higher refractive index. So two light rays strike the glass. This is glass A and this one is glass B. The imaginary line which is perpendicular to the surface, that's called normal. This angle example is 30, the angle of incidence, and this is also 30. It should be a straight line. 30. Now when it travel from air to glass, it bend towards the normal. It changes the direction and it bend towards the normal. For A, for glass A changes the angle, and the angle of refraction is example 18 degrees. But for glass B, the angle of refraction is 10 degree. So which glass bend the light most? So which glass bend the light most? For the glass A changes the angle of from 30 to 18, but glass B changes the angle of incidence from 30 to angle of refraction of 10. So which one bend the light most, A or B? Which one bend the light most? Which changes the direction of the light more? Which reduces the angle, greater reduction in the angle? So for A, it was 30, the angle was 30 and it changes to 18. So what is the change here from 30 to 18? The change is only 12 degree. But for B, it was 30, it changes to 10. So if 30 changes to 10, what is the change in the angle? That is 20. So it means B bend the light more than A. So B bend the light more than A. It means B is having higher refractive index and A is having smaller refractive index. Is it clear? The concept of refractive index. Refractive index means ability of the glass to bend the light. The one which show the light, which bend the light more, which cause a change in the angle from incident to refraction, greater change in the angle, it means that glass is having a higher value of refractive index. Is it clear? The concept of refractive index. So refractive index is refers to ability of the medium to bend the light. Another example, say we have two different glasses. Right now I'm not giving the value, but you should be able to identify by looking at the figure. You should recognize this is a normal which is perpendicular to the surface. Which glass appear to have a higher refractive index, A or B? Which glass bend the light more, which reduce, which is making the angle of refraction very small? So which glass is having a higher value of a refractive index, A or B? Which is bending the light more? Like if I say this angle is 40 and this angle is 20. Here this is 40, but the angle is example 7. So which is bending the light more? Which cause greater change in the angle? A or B? So B is the right answer. B is causing a greater change in angle. So it means B is having a higher refractive index. and A is having a lower refractive index. So the concept of the refractive index is simply the ability of the medium to bend light. If it is having a higher or greater ability to bend light, it means it is having greater refractive index. Then how to calculate the refractive index? So example, you have two glasses. The ray of the light incident, because what is the tendency of the glass? The glass tendency is to bend the light as it's the ray of the light slow down. So example, when we check the angles, say this angle was 45, the angle of incidence, and this angle is 30. Here the angle was 45 and this angle is 40. So what is the change in the angle? How much when the light travel from air to glass, how much the angle changes? Originally it was 45 and then it changes to 40. So what is the change in angle? Only 5. So 5-degree change in angle is caused by B. But when we check the change in angle for A, it was 45, it changed to 30. So if 45 changed to 30, what is the change in the angle from 45 to 30? It means 15. So glass A cause greater change in the angle, greater decrease in the angle as compared to glass B, or glass A is causing a greater bending compared to glass B. So we'll say glass A is having a higher refractive index or greater ability to bend light, whereas glass B is having lower refractive index, or we can say smaller ability to bend the light. Both are bending light, but comparatively A is bending the light more than B. That's why A is having a higher refractive index. So ability of the medium to the bend light is known as refractive index. And how to calculate the refractive index? So there are three formulas of refractive index. If the light travel from air to glass, the formula to calculate refractive index is denoted by letter N. So refractive index is N is equals to sine angle I over sine angle R. This is a formula. On your scientific calculator, you can find this trigonometric function sine. So this is a mathematical function sine I over sine R. If the light is traveling from glass to air, then the formula of the refractive index, the formula which we will use from glass to air, it is sine R over sine I. And if speeds are given, if they provide you the speed, Then the formula for the refractive index, which is n is equals to speed of the light in air divided by speed of the light in medium, or you can say glass or water, anything. So these are the three formulas which we can use to calculate the refractive index. So the concept of the refractive index is ability of the medium to bend the light. Tendency of a medium to bend the light, we call that as refractive index, which can be calculated by three formulas. How to use these formulas, that we'll discuss tomorrow. So any question related to the class today, as we started the topic light and we discussed the reflection of the light, how the image is formed by the plane mirror, and how the light refract or changes the direction when it travels from one medium to another. So I'll end the session and share this with you.